When graphing on a number line, you probably remember that when you have a filled circle, that means that you include that number in your answer. When you have an empty circle, that means you do not include that number in the answer, but that's your starting point. Also, we're adding to that, instead of having filled circles, you may see brackets, and that's what we'll use to write our notation. And then for an empty circle, we'll use parentheses. Then there's infinity. Negative infinity extends forever out this way, because this is where the negative numbers are. And positive infinity extends out this way, because that's where the positive numbers are. And the infinity symbol is just an 8 that's laying down. And you always use parentheses with the infinities. Negative infinity is always on the left, and positive infinity is always on the right. So if we look at this, we have an empty circle at 1, and it's extending forever in the negative direction. So negative infinity is always on the left, and it always has a parentheses. So we're going to have, sorry about that, negative infinity, and notice it has a parentheses because the smallest is always on the left, largest is on the right, and it's at a 1. Now it's an empty circle, so we're going to have a parentheses. If the circle had been filled in, we would have a bracket there. So it looks like negative infinity and 1. It looks like this one is it because it has parentheses on both sides. Absolute value. Absolute value of a number is how far it is from 0. Absolute value is always positive. So in this case, you can see it has the answer there. If you hit the key, that will give you the answer. Notice it also has the video, that you can look at a video that explains it. And then there's message instructor. If you click on message instructor, your instructor, Mr. Allen, will come up. It says to choose the person. And then underneath it, it should be my name, and you can choose my name or his name, whichever one you want, and it will send a message, and it will show us the problem that you're working on with your exact numbers. So this one, absolute value of negative 94 is positive 94. Simplify the expression completely. So we have a monomial on top, a monomial on bottom. We're going to look at our coefficients, the 19 and 10, and see if we can reduce those. Then we're going to look at the x's, and then we're going to look at the y's. Now remember, when dealing with exponents, when we divide, we keep the base and we subtract the exponents. When we multiply, we keep the base and add the exponents. Well, we're dividing here. You first want to make sure all the exponents are positive. If you had a negative exponent, say that x to the 7th was x to the negative 7th, you would move it to the top and make it x to the positive 7th. So if you have a negative exponent, all you have to do is change its position, and that will make it a positive exponent. And it's much easier to deal with positive exponents. All right, so let's begin. We start with the coefficients 19 and 10. 19 is prime, so there's nothing common between a 19 and 10. So there's nothing we can do there. Then we're looking at the x's. I'm going to separate these out so you can see what I mean. We have x to the 14th and x to the 7th. So on my answer, I already know 19 and 10 are not changing. I have more x's on the top. And so if I take the 7 away that's on the bottom from the 14 on the top, that's going to leave me 7. So notice I'm dividing x to the 14th by x to the 7th, so I subtract my exponents. 14 minus 7 is 7. And you always want, wherever, if you're dealing with positive exponents, wherever you have the most, that's where they end up. The others cancel out and go away. And then on the y's, we have y to the 15th. And y to the 8th on bottom, more y's on top, so that's where our y's are going to end up. 15 minus 8 is 7. So this is our answer. Now, we would not combine the x and y because they're not the same base. X is different from y. And don't use your calculator and divide out and get a decimal number. Leave it as a fraction. All right, these are monomials, but they're a little bit more complicated. Remember, when we multiply, we keep the base and add the exponents. When we divide, we keep the base and subtract the exponents. And this one also has a power raised to another power. When you have a power raised to another power, like this, we have q squared raised to the fourth. That's when you multiply those exponents. So that would be q to the eighth. 4 times 2 is 8. So what I'm going to do is I'm going to simplify the top, because I notice on the top I have that q to the second raised to the fourth that I can simplify. And then on the bottom I have two separate p's, so I want to gather those up. So I have 32, p to the 6, and that's going to be q to the 8th. On the bottom I have a 16. Now notice I have a p and then a p squared, and those are all multiplying. You don't see a plus or a minus, so it's all one term, a monomial. It's all multiplying. 16 times p times q to the 7th times p to the p squared. So that's really going to give me p cubed, because if there's not an exponent showing on a letter, it's understood to be 1. So that's really p to the first times p squared. 1 plus 2 is 3. And then I'm just going to rewrite my q to the 7th. So now let's start simplifying. 16 and 32, those cancel. 16 will go into 16 once, 16 goes into 32 twice. So that means I have a 2 in the numerator. I notice I have all positive exponents. I have p to the 6 over p cubed, so I have more p's on the top. And I'm going to take those 3 away from the 6 that I have, and that's going to leave me 3. And then on the next one, q to the 8th over q to the 7th, I have more q's on top, so that's going to give me just q, or q to the first. If you put a 1 there, it's not going to count it wrong. And notice all of these went away because I canceled with that, so I don't have a denominator, or rather my denominator is 1, but that's not simplified, so don't write that. That's 2p cubed times q. That is my answer. No 1 on bottom. Now if the 1 was on top, you have to have it. 1 on the bottom, you don't. You want to reduce it. Yeah, this is a nice one. Anything raised to the 0 power. See that 0? Everything's in parentheses raised to the 0. That answer is going to be 1.